right, guys, today what we're going to talk about, anybody have a clue? Geometry, yes. We're going to be looking at the Georgia State Standard of find the area of right triangles, other triangles, special quadrilaterals, and polygons by composing into rectangles or decomposing into triangles and other shapes. Then we're going to apply these techniques to real-world examples and mathematical problems. The first thing I need us to do, though, is in front of you, you have a prior knowledge skills assessment. This is something that's going to help us guide what we need to look at a little bit more in depth throughout the unit. So the first thing we're going to do is this assessment, and it is our OYO for about 10 minutes. And what is OYO? Which is what kind of noise level? Silence. All right, I would need to know what you know, not what your neighbors know. Okay? Prior skills assessment addresses the different standards that we've already covered or that the students should know in order to be able to be successful in this unit. And so I use the data from that to kind of group them with who needs to be where. A lot of times I will put a stronger student with maybe somebody who's not quite as secure in that, just to kind of help each other along. One can teach and the other can get a little bit better at the prior skills that they should already have mastered at this point. All right, guys, if you will take your pre-assessment and pass it to one person collected, I'll come around and get it in just a minute, okay? I'm going to take a look at these tonight. So the first thing we're going to look at are squares. I know you've heard and seen this shape before, yes? Okay. Who can tell me something special about this shape? Now, it has a name, so we know that it has to be special in some way. Who can tell me? Jacob.
It's a quadrilateral.
It's a quadrilateral. That's a big vocabulary word. What does that mean?
It has 4 sides.
It has 4 sides. Very good. Let's see if we can count that. 1, 2, 3, 4. Yes. Okay, what else is special about this square? Timothy.
They have 2 sets of parallel lines.
Very good. Good use of the word parallel. Excellent vocabulary. Which of the lines in this square are parallel to each other?
Well, the ones going up on the two side ones that go up.
Okay, here and here?
Yeah.
Very good. And what else?
And the 2 horizontal lines that go side to side.
Side to side. Very good. Very good use of vocabulary. I love that. What does it mean to be parallel? Ryan?
To where the lines keep going and won't touch for as long as they go.
Very good. Never ever touch. They'll never cross. They'll never get closer. They'll never get further away. They stay at the same distance away from one another forever. Okay. What else is special about this shape? Yes, ma'am.
All the sides are congruent.
Listen to this vocabulary. I love it. So you've heard about squares before. Very good. So 4 congruent sides. So I'm going to underline these vocabulary words that we're checking out. Can you tell me what congruent means?
Equal.
Equal. Very good. It's that fancy geometry word for equal, right? Congruent. Very good. Tell me something else, Greg.
It has 4 right angles.
4 right angles. The corners make 4 right angles. Very good. Has 4 right angles. Can anybody tell me something about this right angles business? Hannah.
Each angle is 90 degrees.
90 degrees. Very good. That's going to come in handy later on when we talk about finding the area of different shapes, okay? So we need to remember that a right angle is how many degrees?
90.
90 degrees, and a 90 degree is a
Right angle.
There you go. I'm just making you restate it. I love it. Okay, so what I need you to do is as we complete this chart, in your notebook, we're going to add this to our notes, okay? So you should have a section. If not, go to your next available page in your math notebook. You can just go to your next available page. We use an interactive notebook, and so what we do is divide it into our 7 units of study, and inside their notebooks we use thinking maps, we use graphic organizers, we use foldables and things like that to just give them multiple ways to represent the information. I think it's very important that students see it in multiple ways. They hear it, they do it, they write it down, they practice, they do all the sorts of things to reinforce those math skills. All right, guys, so for our last thing we're going to do today is I want you to think about all the shapes that we've talked about, okay? We've talked about our square, rectangle, trapezoid, parallelogram, and then several different types of triangles, special triangles, right? So what I would like you to do is talk to your across the table neighbor, okay? So the person across from you. I want you to choose one shape in your mind, okay? And I want you to describe it to your partner. Now your directions are right up here if you need to refresh your memory. Okay, so your partner should guess based on your description. For example, I might say, I have 4 right angles, I'm a quadrilateral, all of my sides are congruent. What am I?
A square.
A square. Everybody see? Okay, you can do a couple here if y'all will work it out so you have 3 discussions here, okay? All right, so take a few minutes to do that, please.
I'm a quadrilateral that has 4 sides. I'm congruent on all of these 4 sides. All of me are rectangles, but not all rectangles are me. All my angles are 90 degrees, and I have 2 sets of parallel sides. What am I?
Are you a square?
Yes. Your turn.
I have 2 sets of parallel sides. I have 2 sets of congruent sides. I have 90-degree angles. I am a quadrilateral. I have 4 sides and 4 angles. What am I?
Are you a rectangle?
Yes.
There are 4 types of me. I have 3 sides, and I usually have acute angles, except for one type of me. Yeah. What am I?
Are you a triangle?
Yes.
Okay. I have 1 parallel side. I can fit 2 triangles inside of me. I have 2 acute angles. What am I?
Are you a trapezoid?
Yes.
Yes. Okay.
The IWitness News activity, the students are connected to the classroom through a program called Zoom. It's a free video conferencing software that you can download to the computer, and there's an app for iPhones. I think it's also Android based. We have one-to-one iPads in here, and so the students can easily take that device and go from place to place, and we're still connected in the classroom. So y'all are getting to your location. As soon as you get there, give me a thumbs up, okay? All right, so you guys, what we're going to do is they're going to be live on location. When it's their turn to speak, they'll become full screen, and we will be able to see them, and they will give us our eyewitness news on the shapes that they found. The activity itself allows us to go see the different shapes in different locations. Like one day we were trying to find a trapezoid, and the students were like, there's only rectangles and squares and triangles in the building. And I said, well, think about where you might find, or what does a trapezoid look like? And so we were connected through Zoom, and they were walking upstairs, and I heard somebody go, wait, there's a trapezoid. And on the stairwell where the stairs meet the bricks, one of the bricks was cut into like a trapezoid shape to fit up with the stairwell. And it was just kind of it was an aha moment for the students.
So this one of these, I don't know which one. I'm guessing this one. I can. There we go. Okay. Here, Grant, hold that. So this point is exactly 1 centimeter. The base is 1 centimeter, and then I'm guessing this is like 2. This is 2 centimeters.
It's
So,
nice.
or the height. Yeah, it's an isosceles triangle, and the height is 2 centimeters, and then the base is 1. And so to find the area, it would be base times height, which is 2 times 1, and it's just 2 divided by 2, which is 1. So
Where did you get the division?
divided by triangle? Base times height divided by 2.
Althea.
Yes.
Oh, right.
Very good. But can you
Okay.
find me a bigger shape? All right, Jamari, Michael, and Antoinette, are you ready?
Yes, ma'am.
All right, you're up.
Okay, hey Miss Bay's class. It's Antoinette, Michael, and Jamari live from the registrar's office. We decided to measure this old yearbook on one of the shelves. And we got the length as 28 centimeters and the width as 21.5 centimeters.
So
We got the area. We got an area of 602 centimeters squared by multiplying the length times width, and we added up all the side lengths and got 99 centimeters for our perimeter.
Back to you, Miss Bailey.
All right, thank you guys.
I would describe Miss Bailey's classroom environment as controlled chaos. It's not unusual to come in and see the students doing a lot of different things with the lesson. They might be in the hallway working as a group, filming something, or just working, or they might be in the classroom as a group, or sometimes even just in traditional rows. They could be somewhere else in the building working, and then within the group they are working together. There's a lot of collaborative learning going on between the students. There's not a lot of just direct instruction. Once sort of that introduction and mini lesson time are over, the students really are working with their groups or working independently. Again, there's a lot of technology being used in the classroom between their iPads or any other, the Chromebooks, and just textbooks, just all integrating in together seamlessly.
We worked with our county office, and we got, through like a grant, a direct-to-discovery grant, we got iPads, and she was one of the first teachers to do that. And I think it has just sort of exploded for Miss Bailey since then. Every new piece of technology that we could get probably goes through her room first. Just with the 3D printing, video conferencing units, it starts here.
All right, ladies and gentlemen, you should on your desk have a larger triangle and two smaller triangles, a square and a parallelogram. Easy for me to say. What I want you to do, you also have grid paper. What I'd like you to do is the first thing I want you to do is create a shape out of the 5 shapes that I've given you, okay? Any kind of design. Make sure you kind of line it up with the grid paper. It just makes it easier in a little while for what we're going to do next. But you can create any kind of shape you want. So lay it out in a design, and I'll come around and just see what you come up with, okay? It doesn't matter what it looks like. The standard is to compose and decompose composite figures. And so before we even talk about that, I have the students create a design. Sometimes I give them a certain amount. I usually limit the number of pieces they can have so that it doesn't get out of control. But I have them create a design with using the pieces, the 10-gram pieces on their graph paper, and then have them outline it and then trade with someone, because they know that they use triangles and rectangles and squares or whatever, but their neighbor might not know. So they trade with them, and then they have to decompose that into shapes that we already know about. Okay, so we've created this shape. What is this figure made out of? Michael?
A bunch of different shapes.
Other shapes. Okay, very good. What do we call a shape or a figure that's made up of other shapes? Greg?
It's called a composite figure.
A composite figure. What does the word composite mean? Timothy?
It doesn't have it's not a regular shape. It has different sides and lengths.
Good. What else do we know about the word composite? Yes.
More than one? More than one shape?
Something is made up of more than one thing, right? We can have composite in a lot of different things. Maybe if we're a composite sketch artist, what does that mean? What do we do if we're a composite sketch artist? And we work for the FBI. What does that mean? Yes?
You draw criminals, maybe?
Draw criminals, okay. From what, though? If I'm composite sketch artist. Lily?
You put pieces together from different clues.
Very good. All right, so we're going to be, you are a composite sketch artist, okay? You have this shape now that you created. I want you to trade with your neighbor. Trade your paper with your neighbor. Now, we all know that this is a composite figure, which means it's been created from smaller shapes. Our goal, okay, is to find the area and perimeter of this shape by breaking it down into those smaller pieces and finding out what pieces it was originally made out of, okay? Now, I see some of you guys were kind of sneaky and made a square. Goodness. But what you have to understand is you have to break it down into how many shapes do we all have? 5. So I want you to take a little while, okay? And you can talk quietly amongst your group. But what you're going to do is you're going to break it down into those 5 shapes and find the area and perimeter, because we already know how to find the area and perimeter of all these different shapes. Let's go over it one more time. Who can tell me the formula for finding the area of a triangle? Sadie.
Base times height divided by 2.
Excellent. Very good. We have our base at the bottom. Our height goes up and down and perpendicular to the base at a 90-degree angle, and then we divide it by 2. Excellent. This square, how do I find the area of a square? Greg.
This one of the side lengths to the second power.
Very good. So side squared. How else, if I couldn't remember that, side squared, if it were maybe a rectangle, because they're very similar.
Length times width.
Length times width. Very good. Side times side. Length times width. Ooh, tricky one. What is this? What is this? A parallelogram. What was special about a parallelogram? It has 2 sets of parallel lines. What else had 2 sets of parallel lines? A rectangle. Okay. And this kind of looks like a rectangle that's been slanted or smooshed a little bit. Okay. How do I find the area of a parallelogram?
Length times width, length times height.
Length times height. Or we might say, what did we say instead of that length? We call it a base. Base times height. Very good. All right, so those are our 5 shapes. You have 3 triangles, a square, and a parallelogram. So you're going to decompose. If we look back at our standard here, we are going to decompose into triangles and other shapes and find the area. And then I also want you to find the perimeter. I'm going to bring around some rulers to help you find that if you don't want to use the squares. Okay? Everybody understand? All right. Let's start working. You cannot use your shapes to do it. You cannot use the shapes to help guide you. So go ahead and remove them off. You have to figure it out. Okay? So once they have decomposed the shape into the smaller shapes, then they apply the knowledge of finding area of those 2-dimensional shapes and find the area of the composite figure by breaking it down and just finding the little pieces of this triangle and this rectangle and then adding them all together. So it kind of brings it all together for them, I think. All right, ladies and gentlemen, what you're going to do now is I want you to talk to the neighbor across the table and describe to them how you decomposed this figure and found the area, okay? Now, as I was walking around, I noticed that several folks did it in different ways, and that's okay, that's cool. I just want you to make sure that you're describing it and also make sure we use what?
Okay.
Boom, appropriate vocabulary, very good. All right, let's go.
Okay, so for mine, I found the 2 small triangles, 1 big triangle, the square, and the parallelogram. And for the parallelogram, I got 16 centimeters squared. And then I did length times width with the square, and I got 12.25 centimeters squared. And then for the 2 small triangles, I got 8.25 centimeters squared. And then for the big triangle, I got 14 centimeters squared, and I added all that up and I got 58.75 centimeters squared.
Cool, I never thought about that. Well, what I did was I put it into squares, and then I counted up all the actual squares, and then I added that all up. So I had 41 big squares, which is 41 centimeters squared, and then the other ones were half of a square, so I just added up all of those, and I got 22 centimeters squared because there's 22, so I divided it by 2 because each of them are half. So I got 11, so 11 plus 41 equals 52 centimeters squared.
That's almost exactly the same as mine. Cool.
The students were creating a 3-dimensional object. I let them choose. We talk about rectangular prisms and triangular prisms. And so they decided to model a rectangular prism, and so they used a program called SketchUp. It's free. The reason I like the SketchUp and them creating it on the computer is because it starts out as a rectangle and kind of gives them that ability to visualize the third dimension that comes up and makes the thing a three-dimensional shape. And so they can also rotate it and look at it from different angles without actually having something physically in their hand. They can design whatever size shape they wanted to have. And then we can actually take that and turn it into a file for our 3D printer and print it out, so they can take it from that visual concept to something physical that they can have in their hand.
Then we find height, which is 3 foot 8. 3 foot 8.
Okay, and then
And we just multiply it all. And 18. We're gonna do it by the whole inches.
18 times 8.
Times 3.
Yeah.
And the overall volume of inches is 432 inches cubed. We add cubed because that's the unit of volume.
There's this idea that we have to either teach to the test or that we have classrooms that are just all fun. And when I talk about Miss Bailey's class being fun, learning is taking place. I mean, these kids could probably teach other kids, and sometimes they do. They go out and they go into other classrooms and they talk with other students and they tutor other students. So I think that, yes, testing is important, and we realize that we're all sort of held to that. You know, these are the standards. You have to cover these standards. The kids are going to be assessed over these standards, but that we can't just stick to the sit in your seat and let's read this and then let's take this test, because that's not what the kids are used to anymore. I mean, we know that there is so much technology that they're exposed to in their homes. They have cell phones, they have music. There's so much out there that I think that traditional classroom that maybe some of us were used to when we were growing up and going through school just doesn't hold their attention anymore. So if, as the teacher, if I don't choose to sort of think outside the box and look for new ways to present that same information, then I'm not going to reach those standards and I'm not going to have the results on those assessments.
In the final performance task, the students are asked to find the volume and the surface area of our classroom, or they can choose multiple objects within the classroom. At this point, we've finished up all of the different aspects of the geometry unit. We've talked about our two-dimensional shapes, we've talked about our three-dimensional shapes, and finding the volume of those. So a lot of things you find in the school are that rectangular prism or aspects of that. So, for example, the classroom is a rectangle with a few doorways and things like that, and so it allows the students to kind of put all of this knowledge that they've been gathering throughout the unit together into one giant real-world situation. Today what we're going to do is we're going to start a performance task. What you're going to do is you are going to go around the room and find 1 to 3 items, any of the shapes that we've discussed so far in this unit, okay? And you're going to find the area. If it's a two-dimensional shape, you're going to find the area and perimeter. If it's a three-dimensional space, you're going to find the volume and the surface area, okay? So remember, stick to the things that we have discussed in this unit for right now, okay? When you go about the room, you use whatever measuring tool you have. Some folks have meter sticks, some have rulers, some have measuring tapes, okay? So it depends on what type of measurement unit you have, whether you use centimeters or inches or feet or meters, okay? Also, make sure you take note of it in Notability or another app similar to that. You could use the Google Doc if you'd like, okay? Everybody understand? Okay. All right, so you can go find your area, find your location. Go in pairs. If they're doing something with their iPad, it's not something that, it's not just a replacement. We talk a lot about the SAMR model, moving up from that just replacement to actually innovating and creating. And so a lot of assignments that I give when they're in the classroom they're creating something. They're not just replacing that paper and pencil with an app called Notability, which where they can write their notes. They're creating videos, they're creating how-to videos, they are designing their own app to fit the content that we want to talk about. At the end of the performance task, the students will take whatever information they found. So for example, if I found the volume and the surface area of the classroom to find out how much paint I would need, how much air I would need in the room, if I wanted to turn it into a swimming pool, how much water would I need in here. When they're finished with that, they have to present it in some way. I usually allow that to be open to whatever they want. They could create a video, they could create a presentation, just stand up and talk, any kind of presentation they want. All right, guys, today we're going to start our presentations for our performance task. Remember, we have found the area, volume, perimeter, surface area of all kinds of different shapes around the building and our classroom. And so today we have Greg and Jessica that are going to come and present what they found in our classroom.
Well, here's our picture, and this is basically what the room looks like. The little holes versus 82 inches, 40 inches, and 40 inches, 80 inches. Those are the doorways of the classroom.
The longest side of the room is 344 plus 80 plus 82 inches long. In total, that is 506 inches.
The shorter side of the room is 24 feet and 40 inches. So the 24 feet, we had to convert to inches so we can add them up easier. 24 feet is 288 inches. 288 plus 40 is 328 inches.
The area of the room is length times width, and then you will have to take out the area of the doorways. One is 40 by 82 inches and the other is 40 by 80.
The area was 506 inches times 328 inches. Then we had to subtract the doorways, which is 40 by 80 plus 40 by 82.
The area is 165,968 minus 6,480. This equals 159,488 inches squared.
Thank you. Y'all can have a seat. If I could give some advice to any teacher wanting to integrate technology, my biggest advice would be to just try it. Just do it. Just get that technology into the classroom and see what your kids can do. Now, a lot of times that's hard for teachers to relinquish that control that they have over, I want to make sure that everybody is on this page. I can say turn to page 400 and I want everybody on this page. But with the technology, the cool thing is students can be doing whatever they need to do that fits them. And so the biggest obstacle a lot of times is that letting go of the control for that. And so that would be my advice, is to just do it, just try it.